Hello. In this video, we are going to talk about derived unit and how are they expressed in terms of the SI unit of fundamental quantities. So in this, the first we are going to see area. Area, the definition is length into breadth, and length is measured in meters, and so is breadth. So therefore, this is meter into meter, and meter squared is the SI unit. So the second one, if we talk about volume, so volume is length into breadth into height. And that will be meter into meter into meter. So that will be length into breadth will be meter cube. Next, we can talk about velocity. This is same for speed. It is distance traveled upon time. So this is the definition. Distance is measured in meter and time is measured in second. So this is meter per second. Then we have acceleration. Acceleration is defined as change in velocity upon time. So change in velocity will have dimensions of velocity, that is meter per second upon second. So that will be meter per second squared, which will be written as meter s minus 2, that is meter per second squared. Now from acceleration, if we move towards force, so force is defined as mass times acceleration. So mass is measured in kilograms and acceleration is measured in meter upon seconds squared. So this will be kg meter s minus 2, which is also named as Newton. So Newton is denoted by capital N. So mass, then force, then we can move towards work. Work is force multiplied by displacement. Displacement or distance traveled. So force, we know it is kilogram. Then you have meter upon second squared, and displacement or distance is meters. So that will be kilogram meter squared upon second squared. So that will be kg meter squared second minus 2, which is also called as joule, which is denoted by capital J. So after force and work, we can now talk about power. So power is defined as work upon time. So number 7 is power. Power is work upon time. Now remember, work is all energy. So potential energy, kinetic energy, they will all have the same unit. Okay, so what is work? Work is kilogram meter squared, and you have second squared, and power is, this time is second. So what we get kilogram meter squared and second cubed. So which will be written as kg meter square s minus 3, or it is given by watt. So watt is denoted by capital W. Okay, other than that, we can think of density. Density is mass upon volume. So mass is measured in kilogram. So mass over volume. So mass is measured in kilogram. And volume we have seen above, that is meter cube. So this will be kg meter minus 3. And then we can use this to calculate pressure. So pressure is force upon area. So how do you measure force? We have seen it above, that is mass into acceleration, that is kilogram, and acceleration is meter upon second squared, and area is meter squared. So you can cancel a meter up and down. So you are left with kilogram. This is meter minus 1 and second minus 2. So this is the unit for pressure, kg per meter per second squared, which is also called as Pascal, is denoted by a capital letter P and a small letter A. So this is pressure. Then another unit is momentum. Momentum is mass into velocity. So mass is measured in kilogram and velocity is measured in meter per second. So this will be kg meter per second. Okay, so this we can write it as meter upon second. So there is no other special name given for this. And then we will have frequency. So frequency is something happening how many times, or like number of times that something occurs in a second. So frequency is 1 upon second. So that is S minus 1, or it is called as Hertz, Hertz, which is given by a capital H and a small z. So these are some of the units which we should know about. Another unit which is having a similar name, a similar SI unit as we have seen for work, is for torque. So there is a TORQUE, torque. It is also called as a moment of force. So that is force into displacement. Okay. Now, if I show you for work done also, we have force into displacement. So force is equal to kilogram meter, and this is second squared, and displacement is also meter. So that is kg meter squared second minus 2. But like the way we called work as joule, okay, so torque will not be called as joule. So something that you will study ahead, work is in fact a scalar quantity, which do not require direction, and torque is a vector quantity. Okay, so these are some of the derived quantities and their expression in terms of the SI units of fundamental quantity. Thank you.